Well, hi there. I hope you're going really well, and I hope that you've got your seatbelt fastened because we're going to have a look at an extremely exciting area of maths. It's where geometry meets algebra, and it's something else. It's called loci, and loci is really something. Locus, I'm going to explain to you that this is basically converting a geometrical specification into an algebraic expression. So it's where geometry meets algebra and they have a ball together. It's a Latin word. Locus is a Latin word which means a path, and loci is the plural of path. And I guess that's where all those words like locate and locality, all those things come from that. So let's start the ball rolling here. We've got an equation. We want the equation of the locus of points P satisfying PA equals PB, where A is the point with coordinates 3, 0, and B is the point with coordinates 6 and 4. Now, when it says PA equals PB, they mean the length of the line joining them, straight line joining them. Okay, so let's just start drawing a few things in here. There's 2 points, and there is a line between them, and that is the midpoint of that line, and that's what I'm going to do. I'm going to get you the geometrical or intuitive method of doing this is the first one I'll do, and then if that fails, if you can't kind of think of what to do intuitively, there's always plan B, which is the algebra way of doing it, right? Now, if you think of, I've given the game away, of course, if you think about that, the midpoint is an obvious point, 9 over 2 and 2, that's the average of those 2 points. 3 plus 6 is 9, 9 over 2 is 9 over 2, and 4 plus 0 is 4, divide that by 2 you get 2, so it's the midpoint, and that point is obviously the same distance away from 6 and 4 as it is from 3 and 0, okay? Now, but if you then think of the perpendicular bisector of the line joining those points, everywhere on that perpendicular bisector will be equidistant from A as it is from B. Okay, there it is. There they go, A and B for you and me. Now, let's work out, now that we've established that we're looking for the perpendicular bisector of that line joining A and B, let's work out what that equation of that line would be. You see how interesting this is? So we gave it a geometrical specification, we're turning it into an algebraic equation. So let's start with the equation, or the gradient I should say, joining A and B. That would be, as I've written there, my y1 minus y2 over x1 minus x2, and that comes to 4 over 3, okay? So therefore, for a perpendicular line, we would know that that would have a gradient of minus 3/4, because m1 times m2 equals minus 1 for perpendicular lines. Right, now, I think we've got everything we need now, because we've just got to plug that gradient, that perpendicular line gradient, together with that midpoint into an equation for a straight line, and we've got it, haven't we? Thank you, Mr. Snail. Slither away, and he takes us up to victory. The equation of the line is y equals minus 3/4 x plus c, and we're going to plug in that midpoint now. Yes, and here we go, and c will be revealed to you and me. There it is. Isn't this great? I love it. So therefore we get that, and what happens then? C becomes that. Oh, it's a bit of a nasty looking C, isn't it? However, no problem. It's that thing, 43 over 8, therefore y is equal to minus 3/4 of x plus 43 over 8, and that's what we get, right? Now that was from the geometrical intuitive perspective, guys. Now let's do it. Say, for example, you were just having an off day, or you just couldn't think geometrically. We can still always go to plan B, which is straight algebra, right? So let's do that. Now, let the locus of points be P, x and y are the x and y coordinates, such that PA equals PB. I can feel a page break happening. Yes, I'm going to redraw the whole thing now. Just stand by. Oh, look at that. Now, this time I haven't drawn a perpendicular bisector. I've just tried to draw a point P at coordinates x and y such that it looks like PA length of equals PB length of, kind of. Now, okay, so here we go, algebra city. PA equals PB, therefore, what would that mean in terms of the length of those lines? Now, do you know the equation for the equation for a distance between 2 points? Hope so. It goes like that. That's PA. X minus 6 all squared plus y minus 4 all squared, square root of the whole thing, is the length of PA. And same thing for the equivalent of for PB. Now, this is looking pretty crash hot. So let's square both sides. What do we get? It's getting more exciting. Let's multiply out the brackets now. It's getting pretty messy. That's what it's getting. Oh, I just crossed out those x squareds. That's good. And I think the y squareds are going to go too. That's even better. So I can sniff a straight line happening because there's no square terms, okay? Now let's clean it up a bit. It's a big mess. Right, well, I've done some cleaning up. I've got all the x terms over the left-hand side. I've got the y, well, there was no right-hand side y terms, so that's right. And I've half cleaned up the constants. Looks like 36 plus 16 is 52, and I've brought the 9 from the right-hand side over to be minus 9. That's what I get. Now, there's one more bit of cleaning up here. There it is. Now, I think Mr. Snail's going to take us up and away to victory again, and I think that's going to work out to be the same equation as what we got before. I certainly hope so. Yes, if you cancel out that coefficient of the x term, you'll get it. Yes, thank you, Mr. Box. That is very sweet. I'll take you back and have a look. Can you remember that? Look, y equals minus 3/4 of x plus 43 over 8. Check this out. Back one page. Oh, there you go. There it was. Isn't that great? And we're back to where we started. And did you see the light? I saw the light, and the light was right. So that's mighty good. Okay. So let's move onward, ever onward, to another one now. Find the equation of the locus of points P, satisfying this time PA equals 3, where A is the point with coordinates 2 and 1. Well, that's a bit different. We're not doing an equidistant from 2 points this time. We're doing just a distance from 1 point. Okay, 1 point. I'll show you. Let's draw the thing. There's 2 and 1. That's the point we're considering. That's point A. And now, what I've done, see that little purple cross I've put there? That is a point 3 units away in the horizontal direction forward by 3 units. Here's one backwards horizontally by 3 units. Are you starting to guess? Is that mind of yours ticking over? Tick, 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 tick. Oh, here we go. There's one vertically 3 units, up from 2 and 1, and finally we're going to do one down 3 units from 2 and 1. Now come on, you can see, can't you? Okay, stand by. 5, 4, 3, 2, 1. Kaboom! There it is. It's a circle. It's a circle. That is the locus, and we did it. We did it geometrically, didn't we? Ah, very nice. Hello there, Mr. Circle. You must be feeling good tonight. Now, that is the geometrical intuitive method. Now we've just got to put the equation together, guys. It's a circle. Centre 2 and 1 and radius 3 for you and me. Of course it is. Now that's very easy to come up with for a circle. Yes, makes us smile. There we go. There it is. There it is. Okay. So, that was so easy, Mr. Box. Thank you, Mr. Box. That's the geometrical, intuitive way, yeah? Lots of fun. Now, if you couldn't think of that, here comes the algebraic method, which is just as easy, okay? We're saying we've just got a point P with coordinates x and y, which is 3 units away from 2, 1. That's the point A. Now, if you think of Pythagoras' theorem, this is really what the distance between 2 points is all about. Okay? That distance there, that vertical distance is y minus 1. And the horizontal distance is x minus 2, isn't it? So let's just write Pythagoras' theorem, because we know that the hypotenuse of that triangle has to be 3, because that's what we're doing in this thing. So therefore, PA equals 3, put it into maths, Therefore, we're saying that's the statement of Pythagoras' theorem equals 3 units. Now, come on, we're going to square both sides now. There it is, and that is exactly the same as I got on the left-hand side. Thank you, Mr. Box. So there you go. We've just done a straight line perpendicular bisector in the first question and a neat little smiley circle in the second question. Hey, I'm feeling great. Now here comes another one now. This one's a little bit tricky because we're finding the equation of the locus of points P satisfying PO, which is the origin, P to O is the origin, equals 2 times PA, where A is the point with coordinates 4, 0. Look, this one is geometrically quite mind-bending. I can't figure this one out. There's the point A, there's the origin, and there's, I've labelled everything. Now we've got to work out, let's figure it out, from P to O has to be twice as far as from P to A. Do you get that? The distance from P to O is twice the distance from P to A. So let's try and represent that somehow. I'm afraid I'm geometrically bankrupt here, guys. I can't figure this one out. Maybe you can. But that looks like it's about right, doesn't it? Yeah, from P to A looks about... No, hang on. From P to O looks about twice as far as it is from P to A. Now, geometrically, I'm afraid I don't have any ideas. No, okay? But fear not. Plan B awaits us, okay? Now, I'm just forewarning you that you probably need a chill pill here because this one's Algebra City, okay? Ready, set, go. Right. Armed with our chill pill, off we go. Now, we're saying that P to 0 is twice P to A. So we just use the same old Pythagorean stuff to get what we're talking about. Okay, P to O is just square root of x squared plus y squared. The distance from P to A is it's twice the distance from P to A, which is that thing I've just written there. Okay, now what have I done? I've squared both sides, right? I've squared both sides, and we're going to get Mr. Snail to take us away to a long battle. Thank you, Mr. Snail. And here we go. X squared plus y squared is 4 times, I've multiplied out the x minus 4 all squared term. Right, now look, just do one thing at a time here. Don't get too excited and don't be an algebra hero, otherwise you'll come unstuck. Okay, so here we go. Well, I've multiplied out that bracket on the right hand side and that's what I've got. Alright, now it's time to simplify a bit. I've taken those left-hand x squared and y squared terms over to the right-hand side, and I've got that, right? Now, you see, I'm noticing that I've got a middle term with that 3x squared as a minus 32x term there, but there's no middle term for the 3y squared. That's all you get for the y squared. So this is telling us, guys, that we have to complete the square with the x squared situation. It's also telling us, because the coefficient of the x squared term being 3 is the same as the coefficient of the y squared term being 3, we've got ourselves a circle. If they were different, as we'll discover in the next presentation, we get a squashed circle, which is an ellipse. They're pretty fun, let me tell you. Now, let's get back to the present. I've got all that. Now, I'm about to start completing the square, so I hope you took that chill pill. Yes, I've got to complete the square. Now, do you know the procedure? Particularly when you've got a coefficient outside the x squared term, you have to be careful. So you take it out, and then you put what's left of the x squared plus the middle term in that bracket. Goodness, I forgot to push the pause button. Sorry. And then close the bracket. Now, do you see I multiplied by, just go to the line above. I multiplied by 3, and then I divided by 3 inside the bracket to compensate. Right? 32 over 3x, leave a space, close the bracket, plus 3y squared is minus 64. Now, here comes the completing of the square in the line that you can just see on the latest line. So 3 times. Okay, inside bracket, x squared minus 32 over 3x. Now, what is half of 32x over, or 32 over 3, I mean? The half of that is 16 over 3, isn't it? That's the term we have to square to complete the square. So you write that next to the 32x over 3 term, and you say plus 16 over 3 all squared, and you immediately minus it, because you don't want to be adding things, otherwise you can't put the equal sign in our equation. Excuse me. Now, are you ready to go to the next line? Do you see what I've done? Have a look. Yes, looks all right, doesn't it? Okay, now, come on, we'll do another line now. And four-wheel drive algebra mode, we've got to get that minus 16 over 3 all squared term out of that bracket, because we don't want it. We don't want it there. So we're going to get rid of it. And to get it out of the bracket, we have to multiply it by 3, because there's a 3 in front of that great big bracket. So watch. Yes, now let's analyse what I've just done. I've basically written the completed square thing as it is. Okay, that's x minus 16 over 3 all squared. It has to be minus 16 over 3 because there's a minus in the line above in front of the 32x over 3. Right, that's the rule. Now, I took the minus 16 over 3 all squared out of the bracket and I multiplied it by 3. Please don't forget to do that, otherwise you fall in a heap. Then, okay, the rest of it's the same as what it was before. Okay, now, we're still cooking along here, and what we better do next, I think, is simplify that 3 times 16 over 3 all squared term with a minus in front, just to make that a bit more civilised. Okay, here we go. Oh, oh, look at that. Goodness. So, okay, so 16 squared is 256, and the 3 squared on the bottom is 9, and then you multiply, you divide, well, it's 3 over 9, which is 1 over 3, so it's 256 over 3. Okay? My goodness, I told you it was going to be a long battle, but we're winning it, we're winning. So now I'm going to get rid of that 256 over 3 from the left to the right-hand side, I think. Yes! Now we better LCM that right-hand side, because it's looking a bit gruesome. And what do we get? That's all right, isn't it? Now, come on, how's your mental arithmetic? What's 192 from 256? Well, it would be 56 plus 8, wouldn't it? Which would be 64, I think. Beautiful. Now, let's divide by 3, and I think where victory is in sight. Victory is in sight. And you get that. Now, there, my friends, is a beautiful looking circle. And it has a centre at 16 over 3 and 0 for the y, and its radius is 8 over 3. How sweet it is. How sweet it is. But could you figure that out geometrically, the intuitive way? I don't think so. I can't. No way. So plan B came and rescued us, and we won the battle, didn't we? Beautiful. Okay, I think this is the last one. Find the equation of the locus of points P satisfying P to M equals P to F, where F is the point with coordinates 3 and 0, and PM is the perpendicular distance from P to the line with equation x equals minus 3. Oh, goodness. That's such a mouthful. We definitely need a graph. Do you want to pause me and just have a look at it and see if you can figure out what they're talking about? Okay, I'll wait. Right. Okay, here we go. This is what I think. There's the distance. There's P. I'm just calling. I can't figure out intuitively what this is, so forget it. So there's a point P, which is going back to F, the point 3, 0, and there's the line, the vertical line x equals minus 3, and the distance from P to that line would be, of course, the perpendicular distance is the minimum distance to get to that line. That'd be that. Now, it's very important that you figure out. I should take a few steps back here. Just a minute. Wait a minute. Now, what are the coordinates of the point M? What are they? Come on. Sorry to be brutalising you here. But look, you can figure it out, can't you? It's a horizontal distance. So there's no vertical component, so we don't have to do Pythagoras' theorem for that distance at all. It's just a horizontal distance. So if you're going from minus 3 to get to x, right? Say you're going from left to right. Well, then you move 3 units to get to the y-axis and another x units to get to x, don't you? So the x, the x coordinate, oh wait a minute, I'm talking about the x coordinate. The x coordinate of course is -3, and the y coordinate of m is just y. Yeah, and the distance is what I was getting all excited about before. The distance is x take -3, destination minus start, which is x plus 3. Now, that's not so hard, is it? A lot of students find that really hard. But look, it's not really if you just break it down into its doable bits. Okay, come on, let's go. We'll do this now. PF equals PM. Well, we have to get Pythagoras happening for the distance from P to F. That's that thing. And P to M is, as I said, it's just x plus 3. So simplify a bit. Square both sides. Voila. Now we better simplify that now. I think we'll be multiplying out those quadratic terms. Yeah. Oh, look, there's some cancelling. Look, x's cancel. Good. And what else can we... Is there anything else? The 9s, I think. Yes, good. Okay, it's looking a lot better. Now, what do we get? Y squared is 12x. Well, Mr. Snail, to victory. Victory is ours. Now, what I'm saying is that y is plus or minus, if you solve it for y, root 12x, right? Root of 12x, okay? Now, that is a square rooty thing, isn't it, right? So, yes, you could look at it that way if you like. Now, that's the answer, Mr. Box, thanks. Now, that is, look at that. That is a parabola on its side. That's what that is, and I drew it in, okay? That's what that is, it's a parabola. And F, I'm getting all physicsy now, F is the focus of the parabola, okay? And I could go on and on about how exciting that stuff is. And the line x equals -3, the vertical line is a funny little beastie called the directrix. But we don't need to know any of that for this. We just need to know how to get the equation, all right? But it's extremely exciting stuff. This is called conics, the land of conics, okay? You can make parabolas, circles, ellipses and hyperbolae all by cutting into a solid cone at certain angles. It's just amazing. Anyway, enough of that. So, alternatively, what I could say is this. Look, guys, this is really interesting. If y squared equals 12x, yeah? Y squared equals 12x. What about if I said x is 1/12 of y squared? And what if I decided to make y the independent variable, okay? And x becomes the one it is dependent on. Pick a value of y, in other words, square it and divide by 12 and you get x. That's what I'm trying to say. That becomes a dependent variable. Now, what if we were to write the graph of that like that? Goodness! Look at that. There's no reason why we can't do that. There's no reason. We're putting the dependent variable on the vertical, the independent variable on the horizontal. Okay? Now, look. If by reorientating that graph you can see immediately above you, you can reorientate that graph in the way that we normally look at, in terms of y being on the vertical and positive x being on the right, you will get exactly the graph you see on the left. Okay? So what I'm really saying to you is, here's the revelation of the day, that a square root function, as you've been used to doing them, they are really just parabolas on their side. Isn't that something? I reckon that's very exciting. So, alright, well that's all I've got for you for this particular session, but I think we had a lot of fun, don't you? So stay tuned for the next exciting instalment, which is going to be squashed circles, or the amazing land of the ellipse. Okay, stay tuned, and see you next time. Bye!